So welcome to Phidgets Education's first webinar. We're really excited to be able to share this new website that we've built with all of you. A little introduction, my name's Ellen. So I've been with Phidgets for about a year now and have been working on this website. So my background is in design research and education. I have my Master's of Education and have been working with Lucas, who's also in this meeting, on building this new website and helping develop the courses. So for those of you new to Phidgets, Phidgets are programmable USB sensors that are used by industries across the world. So about 3 years ago, Lucas and the Phidgets team were thinking these Phidgets are really easy to use and are a great product. Why are we just giving them to industry and professionals when students could be using these products as well? So our whole goal is to get students engaged in real world skills and give them real world training. Most students right now are using toys or other prepackaged education specific products in their classrooms. So we really want to get students engaged in products that are being used by industry and are being used by the everyday engineer or individual. So Phidgets, most Phidgets look something like this. This is a distance Phidget. So there's a small black boxes that will connect to your computer. So to navigate to Phidgets Education, you will want to go to phidgets.com/education. So this is our main education page. It launched about 2 months ago, and we're really excited to be able to share it with you and share all the improvements we've made. So Phidgets are great for students who are working on a Mac or a PC. The courses and content are targeted towards grade 9 to 12 students. And students are required to have a basic knowledge of loops and conditionals, as well as some knowledge of arrays and methods. So really we're targeting a high school student with some computer science knowledge. So throughout this webinar, we will be covering the Getting Started Kit. So the Getting Started Kit, some of you will have these, looks something like this, consists of 2 buttons, 2 LEDs, humidity sensor. So we'll be covering the course that goes along with this kit with Python. So just a bit of an overview of the Phidgets Education website in general. So the tab that educators will be interested in is the Educators tab. So here we will be posting all the resources. So that's where these webinars will live and any other resources that we'll be coming out with in the next month or two to help you use Phidgets in your classrooms. The next tab that you may be interested is Buy. So Buy is where you'll get information about all the Phidgets education products. So that's with like the Getting Started Kit, the Rover Kit, or any individual devices you may want to add to your classroom. Then Contact, if you have any questions, feel free to contact us via this webpage or respond to any of the invitations you received from this webinar. So the most important link for your students on this page will be Learn. So Learn is really where students will be living in this website. If we click on Learn, you'll first notice what are Phidgets. So this explains the basics of what Phidgets are, who uses Phidgets, and the kind of the why are these tools interesting to students. This is a great homework assignment for students or a take-home activity just to learn about what they're going to be doing in their classroom before they get there. Next, you'll notice the 3 different levels. So these are 3 sets of different tutorials and courses. So today we're going to be going over the Getting Started Kit. Device tutorials are how to use individual Phidgets. So all of the education Phidgets will have a device tutorial that goes along with it. Again, they'll look something like this. This is our sonar Phidget. So each of these tutorials will include how to use a fidget, applications of where this fidget is used in the real world, so students get that connection to why they're using the product and why this product is interesting, as well as a practice challenge of using the fidget. So students will actually be able to engage and test out their individual devices. Projects include more complex applications of devices. It also includes our rover kit here. So the rover kit, students assemble it, and we go through how to use all the components of the rover kit, as well as extension projects of that. There are also extension projects for your getting started kit. So students go through the course very quickly, and this is the only fidget you have, they can still use it for more and more projects. And then again, projects that use the individual sensors. So there's things like a cell phone screen timer, a tank level project, a plant monitoring project, and some other really cool, interesting things to do with your fidgets there. But today we're going to be using the Getting Started kit. So to navigate to the Getting Started kit, we just click on the link here. So you can also send your students directly to this page without navigating through Learn. So if you want students just to get in and get started right away, on the side of your box, there will be a link, www.phidgets.com/start. And that will take you directly to this page. So again, your Getting Started kit comes with 6 fidgets. So you have your 2 buttons, your 2 LEDs, your humidity fidget, as well as your vent hub. So, sorry about that. So your vent hub is really an essential fidget that comes with the Getting Started kit. You'll use this in all your projects going forward. It's your main connection between a fidget and your computer. So it's really great. This comes with the Getting Started kit, gets you going. So the Getting Started kit course really consists of 5 sections. So the first section is, 4 sections, is the setting up. So how you build a kit, configure environment, setting your language. Then it moves to your buttons and your LEDs, then your humidity sensor, and then a final challenge. So each section kind of builds on each other. So students get started with the Set My Language and Environment tab. So what's really great about Phidgets education is it is multi-platform and has multiple environments students can code in. So this tutorial, we will be using Python and Thonny. However, you can also use Java with NetBeans and Eclipse, Python with Thonny, PyScripter, or PyCharm, C# with Visual Studio, as well as Swift with Xcode. So no matter what you're using in your classroom, Phidgets will fit in, giving students lots of options and different languages to explore. So if you're interested in using Thonny, you can navigate to www.thonny.org to download this environment. So we really, really like Thonny at Phidgets because it's very simple to use, and it comes bundled with Python. So if your students are trying to download it on their own, they don't have to worry about downloading an IDE and Python and setting everything up. It's really simple, ready to go. So if you're interested, again, that's thonny.org. And then you can download the environment on Windows, Mac, or Linux. And the environment will look like this when you open it. Again, very simple, run button, stop button, super simple. It's very nice. So once you're done picking your language and environment, all you have to do is select Done. And now the entire website is set up to work with Python and Thonny. So it's a really simple way to keep students on track and not get distracted with other languages or information, and it populates everything for them. So if you want to go to a device tutorial now, it would also be in Python. This is indicated by this little icon in the top corner here. So if your students are ever confused about what's happening, it's a good place to first check to make sure they do have the correct language selected. So after selecting their language and environment, students will be ready to assemble their kit. So all the kits come disassembled and have a brief assembly process. I'm not going to go through every step of the assembly process, but as we can see here, we do have images step by step showing how to install each component of your Getting Started kit. So after your students finish assembling their kit, they will want to configure their development environment. So again, students at each step have an opportunity to set their language and environment just in case they somehow find themselves off of the main path that they're using. Again, steps are broken up with images and brief descriptions of each step. Today, I'm going to actually walk through how to set up Thonny and how simple setting up Thonny is. So we want to open Thonny here and go to the top bar and select Tools. Under Tools, you'll want to select Manage Packages. Here, you'll search for Phidget 22 Native and find Package. So if you have any issues finding this, check your spelling on Phidgets 22 Native. That's a common error that happens when configuring. And all you have to do is select Install. After this package installs, we close, and we're ready to use Phidgets. So again, a super simple setup with minimal time and minimal steps. Again, we have a troubleshooting section at the end of the configure section, so students can work through some of the problems on their own. So it's great for keeping independent. Again, the steps are all in the website. So you'll be able to locate them again. And with that, you're ready to go and ready to get into code. So we try to make the setup as simple as possible for students to get them into the code as fast as possible. Really what we're striving to here is to get students in code and problem solving with their Phidgets as quickly as possible without a lot of setup or headaches, just to get things rolling. So in the coding sections, there are really two sections of lessons, Simple Phidgets and Smart Phidgets. So we're going to start with Simple Phidgets. So Simple Phidgets are your LEDs and your buttons. So each lesson slowly but surely builds, adding one component at a time. So if we start with the Blink LED lesson, you will first see a GIF showing students what to expect with their code, a code sample, which will get students up and running quickly. This is a runnable piece of code that will perform the functions that are shown in the GIF so students can see their Phidgets in action right away, followed by a practice section which gets students engaged with their code and troubleshooting. So let's check out this code and see it in action. So we copy the code and paste it into our IDE, in this case, Thonny. Now all we have to do is run our code. So I'll get everyone to look at my video up in the corner as I run this code. So you notice the red LED turns on and off. And I'll do that again just to get everyone to be able to see that. So the LED blinks on and off. So a very simple code sample. So going into the code, each section of the code will have a rollover comment. So each of these comments explains what each piece of this code does. For this one, I'll just walk you through what each section of the code does. So the first thing you'll want to do in any Phidgets program is import the Phidgets library. So for Python, we import the general Phidgets library, as well as whatever object we're using. So in this case, an LED is a digital output object. So we have to also import digital output. This just gives you access to all of the functions that are in the Phidgets library that you've added to Thonny. Next, you will want to create an Phidgets object in your program. So the red LED uses a digital output object. So this is this object represents your Phidget in your program. The next section we have is address. So the first part of address is setting the hub port number. So if you look at your Vint hub, you'll notice there's numbers across the bottom and the top. So setting the hub port number tells your program where to find the Phidget that you want to use. So in this case, we're using the red LED, which is plugged into the Vint hub port 1. Therefore, we set the hub port to 1. So this just tells, again, your program where to find that Phidget. And then for simple Phidgets, we have to set the hub port device or hub port device to true. So the next section is open. So we've created this software object for our Phidgets, and now we've told our program where to find that Phidget. Next, we have to tell our program to start communicating with that Phidget. So we open our Phidget object. Here you'll notice that we have a wait for attachment. It does take a small amount of time for your Phidget to connect the program to your physical Phidget. So we just give it a bit of time to be able to start communicating before we start to use our Phidget. Next, we go to use your Phidgets. So every Phidgets program follows the same basic steps. So you add your Phidgets library, you create your objects, you address, you open, and then you use your Phidgets. So in this case, we set the state of our LED to true, which turns the LED on. We add a sleep timer for 1 second. So this keeps our LED on for 1 second. If we just went from true to false, you wouldn't actually see the LED turn on, or be very difficult to. So we sleep, keeping the LED on for 1 second, and then we turn the LED off. So that's your basic first Phidgets program. Now, we have a practice section to get students engaged in their code, because you might be thinking, my students will copy and paste the code and not look at those comments. So we have questions set up to get students engaged in learning about their code. So for example, modify your code so the LED stays on for 2 seconds. Students have to go into the code and explore what keeps my LED on for any amount of time. So they'll have to scroll over the comments and find where that is. The same thing with modify your code to flash the green LED, hint address. So this is where students go in and find out, okay, what does my address actually do, and how are my Phidgets interacting? So the connection of, it's not the variable name, it's the address section that tells you which Phidget you're actually using. Again, getting students into the code as quickly as possible, and getting students reading and engaging in that code in a more active way, rather than having to read a paragraph and passively learn about the code. They're really in the code right away. And again, we have a troubleshooting section to go through the general problem-solving tips for the lesson, things like getting a timeout error or not being able to see the LED flash because it's too quickly. This really gives students that independence of problem solving on their own and getting more engaged in what's happening. So it's a great independent activity for students. So that's lesson 1 for Blink Your LED. So lesson 2, we move on to our red button. Again, we will have a GIF showing what students can expect from their program. We will have a code sample, again, showing students how the Phidgets actually is working and giving them that physical interaction right away. And then a practice section again. So let's check out this code sample. Again, we copy and we paste it into our Thonny and run. So you notice the button stayed to 0 right now. It is not pressed. You'll notice when I press my button, the state changes to 1. Again, I release 0 and back to 1. So students, again, that's a very simple program and gets students seeing, okay, how does my button actually work? And getting to see that output right away. At the end of every Phidgets program, you do need to, when you're using a loop, you do need to stop your program. If you don't stop your Phidgets program, you may get errors when you start to run your next program. Phidgets can only be used by one program at once. So if students are having issues, make sure their programs have stopped running. Again, our code sample has the rollover explanations on what's happening in each section of code and what each line of code is doing. Again, we're importing the libraries. We're creating an object. In this case, the red button or any buttons are a digital input object. This button happens to be connected to hub port 0. We set the hub port device to true. We get that connection between the physical Phidget and the software object with open, waiting a second to make sure everything's connected. And then we go into using our Phidgets. So create, address, just telling your program where to find your Phidget, and then open, creating that connection. So using our Phidgets here, we use an infinite while loop to use a polling method of collecting our data from our Phidget. So every time this loop runs, it will print the state of the button. There's a sleep time, which makes sure that the button isn't constantly being checked, and it's an interval. So students explore that sleep time in their first practice question. So we get students to modify that sleep time to a couple of different times, just to see how that affects their program's output. So again, getting students engaged in what this code is actually doing and why these certain features are in the code. So we modify our code to print the LED or the green button again. So that's, again, going back to your address, exploring what that's actually doing. And then modify your code to print the button when the state changes. So that's really a more of a challenging question for students and something that will get them thinking and more engaged in their program. Again, we have troubleshooting to get students through those basic common errors that can happen during their program. Again, independent and letting students engage and solve their problems themselves. So then we move on to lesson 3. So this lesson, you use your button and your LEDs together. So both buttons, both LEDs, which completes the simple Phidget portion of your Getting Started kit. using all those simple fidgets together. Again, we have a GIF showing students what happens when they run their code so they know what to expect. And then again, a code sample to get students up and running. So I'm going to skip over running this code sample just because I don't want to take up too much time. I'm a little bit behind. So again, we're importing our Phidgets libraries. Again, a digital input and digital output for the buttons. We're creating our 4 objects because we're using 4 different Phidgets. We need our 4 objects. We are addressing each of our Phidgets. So again, looking at what hub port each of these Phidgets are connected to, as well as setting the hub port device to true to each of the Phidgets. Next, we open all of our Phidgets, creating that connection again between the software and the physical Phidget. And each Phidget will take a second to connect, so we give them that wait time. Then we move on to using our Phidgets. So in this case, again, we're using that polling technique with the infinite loop and the sleep time. And we're going to check each state of the button and turn on the LED, depending on the button and the button state. Again, we go into practice. So for example, modify your code so the LEDs turn off instead of on, modifying your code so the green button controls the green LED, the red button controls the green LED. I think I got that right. Just to get students acknowledging that just because the colors are the same doesn't mean they're connected. So you have to make those connections within your code. And it shows the customizable nature of the Getting Started kit. Then we have more of a challenging question to modify the code to count the number of button presses. So again, that counts on students completing the last lesson, question 3, to only print the button state when the button changes. So it's really more of a challenging questions for students. It gets them into problem solving and using their Phidgets in a more active way. Finally, we have the troubleshooting section at the end. Again, giving students that independence to solve their problems on their own and engage in the errors a little more. Or possible errors even more, I should say. So with that, we've completed lesson 1 through 3, and now we have a practice activity. So the practice activity is a tug of war game. So in fact, the students have completed almost all of the code for this project already, just by doing the practice questions in lesson 1 through 3. So this is really focused on problem solving and connecting those pieces that we've learned before. So we really want, our goal of the course was really to get students in code quickly, get them understanding the individual components, and then give them an opportunity to be creative and put them together. So in this case, each player is assigned a button. You press the button. Whoever presses the button 10 times first wins the tug of war. So again, lesson 3, we just counted the number of button presses. So you can see it carries into the tug of war. We do have solutions for all of the content on this website. We don't post it on our website because we don't want students to find all the solutions. But if you are interested in any solutions, please just contact us and we're happy to share those solutions with you. And with that, we finish. And we're done with Simple Phidgets. So now we move on to Smart Phidgets. So Smart Phidgets are more typical of the Phidget that you will encounter. So things like the light sensor or the sonar sensor, the thumbstick Phidget. All of those devices will be under the category of Smart Phidgets. So let's get started with the smart fidget. So lesson 4, reading temperature. So once again, we have a GIF showing students what they can expect as output. We have our code sample. And we have our practice and troubleshooting. So if we take a look at this code sample, the first thing you notice is it's a lot simpler than the simple Phidgets code. And why is that? Well, it's because the address section isn't present. So the great thing about a smart fidget is you actually don't have to address them in your code in most cases. So the smart fidget will actually communicate and tell your program where it is. And so you can skip that address section. So you just have to add your libraries, create your objects, open your object, and then use your fidget. So let's see this one in action. Run. So as you can see, it's a little warm in the room that I'm in right now at 26 degrees Celsius. If you want to manipulate the temperature, you can hold your fidget. So right now my hands are cold, so it actually makes my temperature go down. Or you can blow on the fidget, which will also change your temperature. During these times, I would recommend holding the fidget rather than blowing on the fidget for obvious reasons. So again, we stop our code before we move on. So convert the temperature data from Celsius to Fahrenheit. So for this, this practice problem, we're giving students a real practical challenge. Oftentimes Fahrenheit will be very useful. If some of you are from the US, Fahrenheit will be the more relatable degrees. Then again, we have our troubleshooting. Again, with common errors. So that's lesson 4, reading your temperature from your humidity fidget. And yes, as Lucas said in the chat, there is a plotter feature in Thania as well, which is an interesting extra feature to explore. So in lesson 5, you're going to be reading the temperature and humidity from your humidity fidget. So you may have found it odd in lesson 1 that a humidity fidget was printing out temperature. Well, in fact, one fidget can have more than one sensor in it. So that's really interesting part about fidgets is each one is unique and different, and some combine different sensors. So for the humidity fidget, you get a 2-for-1. You also will notice that one sensor here can create 2 software objects. So again, we're importing the library. We're creating our 2 software objects because we are measuring humidity and temperature from both sensors in the humidity fidget. We're opening, waiting for the physical fidget to attach to the sensor. So we have to do that for both objects. And then we're using that polling method again to print the humidity and the temperature. So let's see this one in action. So again, you'll see the humidity and temperature being printed. Again, we can hold on to our fidget in our hand to see the humidity and temperature change. As well, you can blow on it. Again, holding it is probably the better choice right now. And again, we stop our program before we move on. Once again, we have our practice section. So in this section, students are mainly going to be practicing their if statements. So again, getting those coding skills active and getting students exploring what this code does in more detail. And really, we don't want students just to be focusing on Phidgets. We want them to be focusing on their coding skills and their problem solving skills during this course, and really get students engaged, seeing the possibilities of code beyond the screen. And again, we have troubleshooting to create that, create the help and the independence for students to do a first round of troubleshooting on their own. So with that, all of the lessons are actually done now. So students only have to complete 5 lessons to understand the entire Getting Started kit. And then we move on to more problem-solving activities and getting students more active and engaged and exploring their interest areas within Phidgets. So for this practice problem at the end of the Smart Phidgets lessons, students will actually combine their LED with their Smart Phidget, with their Humidity Phidget, to create a hot or cold sensor. So if the temperature is within a certain range, they'll turn on their green light. If it's outside of the range, they'll turn on that red LED. Again, students have done most of this coding already. Really, only thing they're adding from the practice in lesson 5 is that LED. So again, they're curating different features that they've already used to create their practice problem. So seeing how the different components fit together. And with that, their Smart Phidgets lessons are complete. And they move on to the final challenge. So the final challenge is building a thermostat, or a mock thermostat. So again, this challenge is really to get students engaged and putting the pieces together that they've learned from each of the lessons in the course they've just learned. So again, they've completed most of the code sections that are required for the thermostat. For example, every time the user presses the green button, increase the temperature by 1. If we go back to our simple Phidgets lessons, lesson 3, I believe question 3, you'll remember students counted their button presses. So really, they're just applying this to a real world setting and taking, again, those components and putting them all together to practice their coding skills and their problem solving skills with the assistance of Phidgets. Again, we have a troubleshooting section at the end of this to go through, again, the basic errors, things like making sure your Phidgets are plugged in and things of that nature. Again, we do have all the solutions for these that we're happy to send to you. Just contact us and let us know what you're looking for, and we can send it over your way. And with that, Phidgets are Getting Started kits our tutorial is done. So the main course of the basics of Phidgets is complete with that, and students can move on to devices or projects, exploring their own interest areas and getting more creative. Again, we didn't want students to be too bogged down with a lot of time into just the Getting Started kit. We really wanted students to have the opportunity to explore the code and explore their own interest within Phidgets and getting students outside of their screen. So again, the Getting Started Kit course is really recommended for grades 9 through 12, students who have experience with loops and conditionals, as well as some experience with arrays and methods is helpful. But you can be the judge of your own students. If you want to curate bits and pieces, that works well. As far as pacing, again, you'll know your students the best. About a week to 2 weeks is generally what we see students completing the course. The course is really a great piece to add to your classroom again, to show students the range of possibilities within computer science. So getting students outside of just their typing and their screen, to get students, again, interacting with real world information, things like humidity, light, distance, and getting students outside of that code and into real world products. It's really great if you have a busier time in your schedule and you need students to be a bit more independent, or need them to have a little bit lighter load of homework because it is physical. If you're using it in the multiple classrooms, taking it home isn't as easy. If you're away for a while, I know that I was a supply teacher for a while, and it can be difficult, especially in a computer science section, to get a teacher in who understands computer science. So this is a great activity for any of those situations. Alternatively, during the shutdown, we did have some teachers send home kits with their students to complete this course independently. So it really worked well for them to keep their classroom up and running during the shutdown. So again, if you're interested in Phidgets, all the information about purchasing Phidgets is in the Buy tab, as well as resources for you in the Educators tab here. And remembering that Phidgets are really tools used by real world industry, not toys. The data that you receive from Phidgets is very accurate. They're very, very durable, which in a classroom is very important. They don't break easily. And they're a really affordable price for students. So we really encourage you to explore the Phidgets website a bit more to get an idea of all the possibilities that can be used. Again, we are a resource here for you, and really don't hesitate to contact us with any questions, or if you have a student with a project idea or anything, feel free to connect with us. We really love connecting with our teachers and getting to know what their students are doing and what their students are excited about. It's really, really exciting for us. And yes, please follow us on Twitter. We have lots of announcements and lots of fun things coming up, different projects. We highlight student projects. It's a really great resource to keep connected and see what's new and what's coming from Phidgets Education. Thank you for coming, and thank you for your interest in Phidgets, and we hope to be chatting with you soon and seeing what you create with Phidgets and what your students create with Phidgets. Again, reach out, connect with us. We really, really love to see what you guys are doing and what your students are doing. It's one of the favorite parts of here at Phidgets.